Welcome back to the GCSE Maths Pro YouTube channel. Today's video is on the hardest Edexcel Indices questions. If you want to look at the past paper questions or find the mark schemes, then I will have them listed in the top right of every slide. So our first one is only question 12, but I feel like a lot of students don't necessarily know how to deal with it. We've been told that ax to the power of 6 and then all of that to the power of 1 over n is equal to 7x cubed. Work out the value of a and the value of n. So we've kind of got two things here. One is obviously index laws that we need to apply, and it's one of the harder index laws, which I feel like a lot of students often get mixed up anyway. If you haven't obviously checked out the previous video, which is on the most common Edexcel Indices questions, then check that one out first, because that will help you with working out this one. But also, when we're asked to find out two different letters, so a and n in this case, we normally need two separate equations. They've obviously only given us one to start with. You can't solve an equation with more than one letter there. So what I'm going to do first is deal with the index law to expand these brackets, get rid of these brackets. So the index law is obviously our third index law, where you have to, whenever you see brackets, you end up multiplying the powers. Technically, we've got a to the power of 1, x to the power of 6, and then 1 over n. So I'm not multiplying a by 1 over n. I'm multiplying the power of 1. So that would be a to the power of 1 over n, and then x to the power of 6 over n if you multiply 6 by 1 over n. That's what's equal to 7x cubed. So I would do that first, and then what I want to do is pick out my two equations. The way that we can do that is by thinking of this more as an identity, which comes up a lot in AQA actually. An identity is where one side is the same thing as the other side, which, I mean, it's kind of implied because it's equal to, isn't it? But instead of thinking of it as an equation where you can move things left or right, think of them as two separate parts that are the same as each other. Or, for example, 7x cubed can also be written as this, or vice versa. What I mean by that is 7 is the coefficient, and then the x cubed is obviously the x value. Do you see how I can relate that then with the other side? A to the power of 1 over n is just a number, it's just a coefficient, isn't it? And then the x to the power of 6 over n is obviously the x value. So that's how I'm going to split them up. So I've got a to the power of 1 over n is the same as 7, and separately I've got x to the power of 6 over n is the same as x to the power of 3. Now the a one I can't solve yet because again I still have two different letters. So let's just look at the x one. We've got two different letters, I know we've got x and n, but really we just want to know n, don't we? We don't need to know the x. The reason being is because if x to the power of 6 over n is the same as x to the power of 3, do you see how I could just focus on the powers and say, well, therefore, 6 over n must be 3? So that's why I'm saying the x didn't really count as a second letter. We don't need to know what x is. Now you can just solve this. You might obviously be able to just figure it out by looking at it, but technically solving it would be this way around, wouldn't it? 6 divided by 3 is 2, so n is 2. That's one of them. Now that we know that n is 2, we can bring it back and sub it into our second equation to find out a. So we've actually got a to the power of 1 over 2, or 1/2. So now we're thinking about fractional powers. What does the power of a half mean? It means square root, doesn't it, in other words? So a, we just have to square both sides, is 49. That's how I would work out this one. Okay, the next question, we've got question 14. This one is now non-calculator. So write 1/16 in the form 4 to the power of n, where n is an integer. So not only do we need to know how to do, let's say, part B like this, where they tell us the powers, and we need to find the value. In this case, they've given us the value, and we need to work backwards to find the power. So you need to know how to kind of work through powers both ways. So what we want to do is write it as 4 to the power of something. So first of all, obviously leave the 1. 16 is what? 4 to the power of what? It's 4 squared. That's our first step. Then, how do I go from 1 over 4 squared to just 4 to the power of something? Well, that is the reciprocal, isn't it? The reciprocal of 4, which relates to a negative indice. So that would be 4 to the power of minus 2. So you see how you had to work backwards to figure out what the original power was. Not only do I need to know if they say what is 4 to the power of minus 2, that it is 1/16, I also need to be able to identify that 1/16 can work backwards into the format of 4 to the power of minus 2. So that's why that one's a bit harder as well. Part B, work out the value of 8 to the power of 5 thirds minus 9 to the power of 3 over 2. So I'm going to work out both of these separately. These are both fractional powers. First of all, 8 to the power of 5 thirds. Fractional powers is where we have some kind of root, first of all. And it's always the denominator, isn't it? So 3 is our denominator. That means cube root. Cube root the 8. And then the numerator is just a normal power then. So you always have to apply the denominator first as a root, and then you can deal with the numerator. Now, they won't make you square root or cube root numbers that are not already square or cube numbers. So they won't make you square root 8, because 8 is not a square number, is it? Hence why they've made us cube root it. So you should have this memorized. The cube root of 8 is 2. Then we need to do 2 to the power of 5, which is just where you do 2 times 2 times 2, 5 times. So you should get 32. Now let's look at the 9. You can probably already see where this is going, because you should know that obviously 9 is a square number. So the denominator is 2, which means normal square root, and then we're going to cube it afterwards. So the square root of 9 is 3. 3 cubed is 27. So now just don't forget that they have actually asked us to subtract them. 32 minus 27 is 5. And there's our answer. So that one I feel like it looks kind of scary, but if you know what to do with fractional powers, then it's actually not that bad. Okay, so our next one is a part B. The part A wasn't really relevant, so I just wanted to focus on this bit here. See, it was from a question 14. Again, obviously, another non-calculator paper. This one is very similar to the question we just did with the 1/16. We need to know how to work backwards from values into indices again. So we've been given 3 to the power of A, 3 to the power of B, 3 to the power of C, and then at the end we need to add together those powers. So first of all, let's look at 3 to the power of A. They've given us 1/9. We want to work this back into being 3, obviously, to the power of something. So first of all, that is, obviously, 9 is 3 squared. And this is very similar to the previous question, isn't it? The 1 over 3 squared is the reciprocal. So that would mean 3 to the power of negative 2. Which tells me that A is negative 2. Next one, 3 to the power of B. They've given us two parts here. We've got a 9 and a root 3. So obviously 9 is 3 squared, and that's multiplied by the square root of 3. How can I write that as 3 to a power? Well, if you think back to the one we just did with the fractional powers, anything to do with roots is always a fraction, isn't it? This is square root. So that would be just a half. Now, we do actually have to use index laws here because we're multiplying, so we add the powers. That would be 3 to the power of 2.5, or I would probably write in decimals in this case, 2.5. So you see how B is 2.5. Now, part C is basically a combination of the previous two. So if you've got the previous two, you can probably work out this one. So we've got 1 over root 3. We've just said that root 3 is 3 to the power of a half. And then previously we said that 1 over something is the reciprocal. So do you see how that would be 3 to the power of negative a half, which in this case I'm going to write as a decimal just to match my other ones. 0.5, isn't it? So C is negative 0.5. Now, don't forget though, they have actually asked us to add them at the end. So I need to do minus 2 plus 2.5, which is 0.5, plus minus 0.5, which is annoyingly just 0. After all of that, the answer is actually just 0. But yeah, it's not even that many marks, but I feel like it's quite tricky to know how to kind of work forwards and backwards with indices. Okay, I've put this one in here. It was question 18, 4 marks. Again, obviously another non-calculator. It just looks a bit overwhelming, doesn't it? There's just a lot going on. We've also now got mixed numbers. So, obviously having worked through the previous ones, you're probably looking at it going, yeah, I know that I've got some kind of square root here, but do you see how 4 and 9 are square numbers, but the 5 isn't? And I feel like that might be where it might throw you off. So what I would do in this case, because we've been asked to work out the value, the actual just number answer, is I think I would convert the mixed numbers into improper fractions. So hopefully you remember how to do that. We just need to take the whole number on the outside, multiply it by the denominator. So that would be 5 times 9, which is 45, plus the 4 at the top, which is the remainder, 49 over 9. Which is looking a bit better because they're now both square numbers, aren't they? I'd probably do the same with the second one. So 4 times 3 is 12, plus 2 is 14. Now that one looks a bit random, doesn't it? We'll just go with it for now. And then 2 to the power of negative 3 is effectively 1 over 2 cubed, which in other words is 1 over 8, isn't it? we should have on cube numbers, I would recommend memorize from 1 to 5. So 1 cubed, well, don't need to memorize that, but 2 cubed, 3 cubed, 4 cubed, 5 cubed. That's what I would recommend for non-calculator. Okay, let's deal with the numerator again, shall we? So we know that the negative power, I tend to do that one first because I feel like I'll forget otherwise, means reciprocal. So that means we need to flip the fraction. Now, let me just write out the rest. Now that we flipped it, the power of a half means square root, so square root both numbers. So that would give us 3 over 7, multiplied by 14 over 3, over 1 over 8. At this point, it's not even indices, is it? It's just basically fractions. So I'm going to multiply the numerator first. So multiplying just straight across. I wouldn't even multiply that actually, because you see how the 3 and the 3 would cancel? 3 in the numerator, 3 in the denominator. So that's effectively 14 over 7 over 1 over 8, which is 14 over 7 is obviously 2, isn't it? So we're left with 2 divided by 1/8, and that's where I would do keep, flip, change. So 2 times, technically 8 over 1, but again, 8 over 1 is just 8. So we've got 2 times 8. So our answer is 16. So this one we had to know a lot about fractions as well as indices. Okay, another question 18 here. Now this one's actually a calculator question. So they've told us we've got 16 to the power of 1/5 multiplied by 2 to the power of x is equal to 8 to the power of 3/4. Work out the exact value of x. So that's telling me it's not going to be a whole number. It's probably going to be decimal fraction, something like that, maybe even a third. So this one, I wouldn't go into trying to fifth root, because you can't do the fifth root of 16, right, without any decimals. I wouldn't literally type that in your calculator, okay, because you're just going to get a load of decimals and it's not going to be helpful. So try and think of it as non-calculator for now. What I would focus on is, you see how we've got 16, 2 and 8, and they're all multiples of 2? We want to effectively solve the equation, so what I would do with this one is convert everything into a base of 2. So what I mean by that is, not like 2 times 8, I mean 2 to the power of what gives me 16? That would be 2 to the power of 4, wouldn't it? So I would convert the 16 into 2 to the power of 4, and then you still have this 1/5 on the outside. Obviously 2 to the power of x is already there. And then same with the 8. That is 2 cubed, isn't it? 2 to the power of 3. Then I would deal with the index law, so we've got the brackets where we need to multiply the powers. So that would be 2 to the power of 4/5 times 2 to the power of x is equal to 2 to the power of 9/4. So we're simplifying this equation a little bit. And the last index law we could use is when we are multiplying, we actually add the powers. So that would be 2 to the power of 4/5 plus x, wouldn't it? And my whole aim is to get the format here. So we've got 2 to the power of something and then equals 2 to the power of something else. I just want one of each 2 on each side, if that makes sense. Because now, similarly to the first question we did, if 2 to the power of this is equal to 2 to the power of this, then I can almost ignore the 2's and I can just write it as 4/5 plus x is equal to 9/4. Like, those two powers must be the same thing, aren't they? Because the base numbers are the same. So for them to be equal, they must have the same powers as well, mustn't they? So I'm just completely forgetting about the 2's for now. All I need to do now is solve this equation. Now it is a calculator, so you can just subtract it in your calculator. And that gives me 29 over 20, which you can leave it like that, because that's an exact format. Or the decimal isn't actually that bad. You can leave it to 1.45. Don't round it though. Don't put 1.5 or don't round it, because they want the exact value. So either of those two answers, as long as you write the complete answer down, is fine. I normally stick with fractions personally. 29 over 20. This is one of those ones where I feel like you need to have seen this kind of type of question before to then know that this is the avenue to go down. Convert everything into the same base number. Okay, so given that we've just done that, this is basically exactly the same question. This one, though, they've said is a non-calculator, which fair, we didn't really need to use the calculator last time, did we? So given that 9 to the power of -1/2 is the same thing or is equal to 27 to the power of 1/4 divided by 3 to the power of x plus 1, find the exact value of x. So you see how we've got the same scenario, except this time it's all multiples of 3. So what I'm going to do is rewrite the 9 and the 27 as 3 to the power of something. So 9 is obviously 3 squared, isn't it? and then to the power of negative half. 27 you should know is 3 cubed to the power of 1/4, and then there's a divide there. 3 to the power of x plus 1, that one's obviously fine. We're going to do exactly the same thing in terms of multiplying the powers. So 2 times negative 1/2 is just negative 1, isn't it? And then 3 times 1/4 is 3/4. This one, because it's non-calculator, you will obviously have to be good at working with fractions as well. That's just kind of implied, isn't it? Then we've got a divide, 3 to the power of x plus 1. And now we've got this index law here, the divide one, which is where we subtract the powers. So 3 to the power of minus 1 is still there on the left. And then on the right, we've got 3/4 subtract all of x plus 1. This is the format I want, isn't it? I want to have just 1 3 on the left and 1 3 on the right. Just one of each base number on the left and the right. Because now I can compare the powers. If these two sides of the equation are equal, then because they've got the same base numbers, the powers must also be the same. They must be equal, mustn't they? Which means I can create my own equation with just the powers. So minus 1 is equal to 3/4 minus the whole of x plus 1. Now I put it in brackets because I want you to not forget that we're obviously subtracting the x, but we're also going to be subtracting the 1. So if I expand out those brackets, that gives me not just obviously minus x, that bit's kind of obvious, isn't it? But also minus 1, so don't get that bit mixed up because otherwise you'll end up with an incorrect answer. Now I just need to solve the equation. First of all, if I add 1 to both sides, they both cancel, don't they? So that's good. And then I would probably just add the x to make it positive. So you see how in this case x is 3/4. You can obviously write it as 0.75 if you like, but I don't see the point really. Either one of that is fine. The exact value is 3/4. So you can see they've asked that same question twice now. So hopefully if you see it again, you'll kind of see the pattern and you'll know exactly what to do. So, thanks for watching these videos on the Edexcel Indices questions. If you haven't already checked out the most common Edexcel Indices questions, go back and have a look at that video. All of them will be linked down below. If you want to go through indices in general again to refresh your memory, I will link those down below as well. Otherwise, thanks for watching this video. If you found it helpful, make sure to like and subscribe and leave down below any questions or comments that you might have.